Hey guys, so I'm back with the second video. So the second video is going to be about IP fragmentation in networking. As you can see here, I've got Wireshark open and I've opened up a packet capture. In this case, you can see 1 to 14 packets, and these are actually packets from a ICMP message that have been fragmented into 7 smaller packets. So there was one big ICMP packet, and that was split into 7 smaller packets. And that is called IP fragmentation. It's pretty much just splitting a big packet into a smaller packet. So why it is required is because if you want to send data from through a route, and the route's maximum transmission unit MTU, if that is smaller than the packet that you're trying to send. For example, if I'm trying to send a packet which is 3000 bytes and the maximum transmission unit of the route that the packet is going to take is 1500 bytes, then the packet needs to be split up because it won't actually fit on that route. So that's what's going on in packet 1 to 7, you can see here. So what usually happens is IP fragmentation occurs, we send the small packets to the receiver, it goes through the route, and then the receiving computer, so now the receiving computer has little packets. It needs to reassemble them. It needs to reassemble them so it can actually have something on the other side. So another thing that is really important is the offset. As you can see, there's this offset here. 0, 1480, and it increases. So the offset pretty much tells the receiving computer how to actually reassemble the small packets that have been sent. So for example, let's say we just wanted to send a string to the other side, which was JOHN, which is John, and we split that up into 2 alphabets, JO and HN. So now, as you know, on the internet, packets can take different routes, so it's not guaranteed that just because I send JO first and then HN second, they will get to the receiver at the right order. So it is possible that HN might get to the receiver before JO. So it needs to know how to actually assemble them in order. So the offset tells us how to do that. But let's just before I explain the fragmentation offset, let's look at the ID. So the ID, in this case, as you can see, they all have the same IDs. That just tells the receiving computer that all these packets belong together and need to be reassembled. All right, so let's just open one of these packets up over here. All right, so as you can see, frame 1, Ethernet, Internet Protocol version, and the data. So this is the data, 1480 bytes. And what you want to look at is the flags over here. This is really important. So the flags, there are 4 flags, as you can see. Reserved bit, not set means it's 0, and set just means it's 1. Don't fragment just tells the receiving computer to not fragment this packet. More fragments just means more fragments are coming, and set, because this is just the first packet, that means more packets will be coming after this one. And the fragment offset is 0, so this is what we'll be talking about. Fragment offset is 0. Alright, so to explain this, I'm just gonna Alright, so now let's just imagine we have this and we know that the length of the first packet in data is 1480 bytes. So let's say the first packet is this big, and let's say this is offset of 0, right? offset just means how much to move the second packet down by, so it can be actually reassembled in order. So the first one has an offset of 0 and it's 1480 bytes long. Now the second packet comes along. And let's look at the flags again. Don't fragment, not set obviously. More fragments is set because more fragments are coming. And then the fragment offset is 185. Now it's kind of confusing. This is actually 185 bytes. So you actually need to multiply this by 8 to get the number of bits because there are 8 bits in a byte. So now then you just need to multiply 185 by 8 and then you'll have the second offset, correct? And obviously the data is just 1480 bytes, so it's the same. So the second offset 185 times 8 is 1480. So this will be obviously at this point how many bits are there? At this point there are 1480. That's because the first packet is 1480. So this is, if this was just a ruler, this is 1480. So this is where the second packet needs to go because the second packet has an offset of 1480, which is 185 times 8 is equal to 1480. And the second packet obviously is, again, obviously this is not to scale, is 1480 bits as well. So now let's look at the third packet. So where do you think the third packet's offset will be? Well, the third packet's offset, that means where should this packet be put on this ruler, or on in what order? So we have 1480 and then we have another 1480, so it'd be 1480 plus 1480, which is 2960. So that's what we think the offset should be. Now let's find out what the actual offset is of the third packet. So this is the third packet here. Let's check it. So don't fragment, not set, more fragments, still set because there's more packets coming, and the fragment offset is 370. So let's multiply 370 by 8 to get the number of bits, which is 2960. And that was right. That's what we got, right? 1480 plus 1480 is also 2960. So this is where on this ruler, if you imagine, the third packet should go. And this is exactly what happens for however number of packets you may have. Alright, so as you can see now, let's expand this one. Number 4, offset 4440, and this is bits by the way here, and 5960, so they're just increasing by 1480, right? And now what's interesting is packet number 7 is actually it's also the last packet and also the reassembled big packet. So if you open this up over here we go, packet 7, you can see flags, not set, don't fragment, not set, and more fragments is now not set. That means there are no more fragments coming. This is the last fragment. And then the fragment offset is 1110. This one's bytes, and it tells us this is ICMP. And if you click on this arrow, you can see all the packets. You know, packet subpacket 1, subpacket 2, 3, 4, 5, 6, 7. And the number of bytes, you see the last one has just 100 bytes and the fragment count is 7. The reassembled length is that. And here you can see the data. Alright. In the next video, I'll be talking about an IP fragmentation attack. Anyway, just before I go, as you can see, the last one also is a echo ping request. So that means when all the packets have been sent, it becomes a big ICMP request on the receiver. So it's a echo ping request. All right, thanks for watching, guys.